So our next step is going to be to deploy the MONs and MGRs. So if you look in our setup, what we have completed so far, we have this final step. So we need one drive allocated per MON for the MON's map data. An additional ease of use croit feature is that MGRs are deployed automatically with the MONs. In some other deployment methods, this would be an additional step. So let's select a drive. On our N1 node and deploy. It's also simple to view logs of tasks. We can easily view the logs in the GUI. And this is going to take a moment. So while this is creating, I'd like to shift gears and talk about our network setup. So we recommend two VLANs, one for croit and one for Ceph. If you look in this diagram as it pertains to the Ceph nodes themselves and the croit management node, one VLAN would be for the croit network. This is used for PXE booting and isolated private network. You can oftentimes use onboard NICs for the servers, although we support tagging. If you are doing tagging plus LACP, we need to make sure that the switches support LACP failback. Usually not a big deal, but you need to check with your switch manufacturer for that model to see if that is supported. In addition to that, we want the Ceph network, so this is going to be used for Ceph communication as well as client communication. So clients will connect in via that network. And then the croit manager needs access to the internet. That's going to be api.croit.io. This is for updates. However, we also support an air-gapped installation, basically completely offline. All right, so our monitor has been created, and if we look, we can see that we are now in the day 2 view of the GUI, so we have a lot more options here than we saw before. In our advisor, we give recommendations, many of which are proactive recommendations, things that we found on the field. In this case, it is telling us that we have too few MONs, so we need to add 2 more MONs to our cluster. So select a disk. If these disks had data on them, we would need to wipe them. We could do that simultaneously by multi-selecting, but in this case it's ready to go. Right click and set to MON. And let's put the other one on node 3. Yeah, ultimately we want to make sure that we have an odd number of MONs. This provides redundancy and helps mitigate cluster split brains. 3 is the most standard. 5 is common for large environments, and rarely do we ever see the need for 7 or more, but it is doable. In addition, the advisor provides just general information, so you will see things pop in there as you use the croit software. So let's move on to management of the drives themselves. I mentioned that we have the ability to wipe. It's as easy as selecting a drive, clicking wipe, typing in to confirm. And we can create OSDs, we can create DB walls. So at this time, I'd like to go ahead and show you how to make DB walls and OSDs. So I have some drives that are NVMe that we are going to make a fast pull with. So we can do things like multi-select, we can select individual, and this just makes it easy to do. Other methods, it's either you give it a command where it blindly grabs all of the disks and puts into a pool, or you have to run a command for each and every disk. So this is easy. We can sort, we can filter, and it just makes it nice and easy. set to OSD. So we are going to co-locate the DB wall on these because these are NVMe drives. We also could encrypt if we liked to do so. We can assign a device class. In this case, we're just going to leave that automatic, and it will create device classes depending on whether it's a solid state drive or an HDD. All right, so while this is going on, let's select some drives that we want to be our DB walls. So click out of that. All right, so we are going to view more disks and multi-select. Actually, let me refresh this screen because we came in here looking for disks for monitor. We knew that we didn't need that on node 1, so it filtered it out. And we can set to DB wall. The number of partitions I'm going to do here is 2. And a little bit more on the DB wall. This is done to shift the metadata IOs to the much faster NVMe's. This is done when you have HDD disks that you're actually dropping the data on. So again, by shifting the metadata IOs to the much faster NVMe, this improves the overall performance and reduces latency. When adding multiple OSDs, they are added simultaneously, but each node adds the OSDs one by one to avoid any potential issues. So every node is adding one by one, but they're doing it simultaneously. So now that we have some DB walls, let's go ahead and create OSDs for our remaining disks. These are our HDD disks. Set to OSD. And instead of being co-located, we are going to have a dedicated DB wall disk that we created. And there we go. So as you can see, 2 of 2 partitions are being populated. That means that each partition is going to have one of the 2 disks per node. So we have 2 HDDs per node that we are adding. And in the background, it's handling all of that for us. We'll give it a few moments just to finish up. And it is done. All right, on to the next step.